Welcome to the Explainer. Today, we're diving into two of Python's most powerful and, let's be honest, most dangerous built-in functions. You've probably heard warnings about them, and if you've ever wondered why they're seen as such a double-edged sword, well, you are in exactly the right place. So let's just start with a kind of a mind-bending idea. What if your code wasn't static? What if it could actually write new code for itself while it was running? This isn't science fiction. It's exactly what eval and exec let you do. And it gets to the very heart of what makes Python so dynamic.
All right, first up, let's really get to know this dynamic duo. They look similar on the surface, but they have totally different jobs. We're going to start with the one that actually gives you something back.
Okay, so think of eval as your own personal pocket calculator. You give it a string, a single line, an expression like 3 plus 4 times 2, and it processes it, does the math, and hands you back the result. In this case, 11. It's built for these little one-liners that need to produce a value.
Now, exec is a whole other beast. It's less like a calculator and more like a tiny little Python interpreter that lives inside your code. You can feed it a whole script as a string. We're talking loops, function definitions, the whole shebang, and it will just run it. Exec doesn't give you a result back. Its whole purpose is to do things, to perform actions, to change the state of your program. And this table really just crystallizes their roles, right? A value is for getting a value back from one expression. Exec is for running a whole block of instructions. And that's the key difference you got to remember. You can't define a function with eval, and you can't get a direct answer from exec. One computes, the other executes. So with this crazy power to run code from just a string, what kind of amazing things can you actually build? Well, the possibilities are actually pretty exciting. The legitimate uses for these are often really clever. A scientific calculator is the classic example. A user types a formula, eval spits out the answer. But the real magic is in things like dynamic plugin systems, where exec lets an application load and run brand new features from a text file, all without ever having to restart. And this shows that plugin idea perfectly. Just imagine your program gets a string of code. Exec runs it, and boom, it defines a new function, maybe export to PDF. All of a sudden, your program, which had no idea how to do that a second ago, now does. It can literally grow new limbs while it's running. And here's the turn. This incredible power, this flexibility, it comes with a very, very dark side. In fact, misusing these functions is one of the oldest and most dangerous security holes in Python programming. Look at this string. If an attacker can trick your program into running this with eval or exec, it is game over. This isn't some complex hack. It's one line of text that uses Python's own built-in features to delete literally every single file on your system. So here's the bottom line. Using evalue or execute on any input you don't personally 100% control and trust, especially anything from a user, is like leaving the keys to your entire server right on the front door with a big welcome sign. So how do we actually use this power safely? Well, we don't have to just throw these tools away. But we absolutely have to build a secure cage for them to run inside of. We have to sandbox them. The secret is actually hidden in the optional arguments for evaluate and execute. We can pass in our own custom dictionaries that tell the code exactly which functions and which variables it's allowed to see. By controlling its world, we control its power. This slide shows the magic trick. See, by default, eval can see a special dictionary called __ built-ins. And that's where all the powerful default Python functions live, like opening files or importing modules. The unsafe code on the left has full access. But on the right, by passing in an empty dictionary for __ built-ins, we've instantly cut off its access to all of those dangerous tools. So what you're doing is building this custom, secure little micro-universe for the code to live in. You start by giving it empty dictionaries for globals and _ built-ins. It's a clean slate, no dangerous functions. Then, you carefully, one by one, add back only the specific, safe tools you want to allow, like basic math functions, into a locals dictionary. The code just can't use what it can't see. But let's be real, building a perfect sandbox is hard. So what if there was a better way? For a lot of common tasks, the best move is to just use a tool that was designed from the ground up to be safe.
And Python's standard library gives us this fantastic function in the AST module. Literal eval has one job and one job only: to safely parse strings that contain Python data structures, things like lists, dictionaries, numbers, and strings. It can't run functions, it can't do math, it only parses data.
And this takeaway is absolutely vital for security. If all you're trying to do is read a string that looks like a list or a dictionary, maybe from a config file or an API, do not use evaluate. Use ast.literal evaluate. It is immune to code injection because it is fundamentally incapable of running code. It just parses data structures. That's it.
Okay, this slide is your final cheat sheet. Let's make it crystal clear. Reading data from some untrusted string? Use ast.literal evaluator. It's safe. Building a math calculator for users? Okay, you can use evaluator, but only inside a really restrictive sandbox. Loading plugin code that you wrote and you trust? Exec is the right tool for that job. For pretty much anything else involving code you don't trust, you're in the high-risk zone and you need to be extremely careful.
You know, eval and exec are the ultimate embodiment of that old phrase, with great power comes great responsibility. They give you this incredible flexibility, but they demand an equal level of caution. So the question isn't just can you use them, but should you? And have you done absolutely everything to make it safe? Thanks for watching.